I'll start with the description of geographical factors that shape the climate. Then I'm gonna talk about the uh, climatic conditions of Svalbard itself. Then I'll talk about the meteorological measurements that are conducted in the Arctic, not only in Hornsund, but also at all meteo stations. And then at the end, I'm gonna finish with the climate change in the Arctic. So what we do observe, how we describe it, and what changes do we observe there. When you think about the Arctic, you have to know that the Arctic, the most part of the Arctic is the Arctic Ocean. That is surrounded by the continents of Eurasia and North America. There are also huge islands such as Greenland and also archipelagos such as Svalbard. There is floating sea ice on the Arctic Ocean, so the North Pole doesn't consist of the land. If you want to reach that, you will have to go onto the floating sea ice. There are few definitions of the Arctic. Most common one is defined by the latitude 66 degrees north, that is visible here. But such definition would cut out the southern part of Greenland, parts also of the Iceland, and also Arctic Canada. So there are also different definitions of the Arctic. For example, another is the green line presented here is the tree line. The other one, the red one, is the 10 degrees Celsius air temperature isotherm in July. And also you can see the blue line that was shown before, that's the Arctic Circle. So according to different specialists, if you talk with the biologists, they can define the Arctic with this green line. So it shows where the trees reach. Above it, there is only tundra vegetation. So for example, for them, it will be different area than for those that use Arctic Circle as the definition of the Arctic. There are multiple factors that affect the weather and climate of the Arctic. The most important one is the latitude, because our Earth is round. So the solar radiation reaches the ground on different parts of the Earth with different angles. For example, close to the equator, the sunlight reaches the ground almost perpendicularly. In case of higher latitudes, such as in the Arctic, the distance of sun rays is longer and they cover larger areas. So it influences, that's the most important factor that influences the climate in the Arctic, but it is also highly dependent on the land and water. So the distance from seas, from oceans, will also affect what's the climate at different locations in the Arctic. So it's not that it's the same throughout the whole Arctic region. It will depend on the location. Another thing is that the Earth's axis is tilted, and depending on the where Earth is during the annual trip around the sun, the northern hemisphere is either tilted towards the sun during summer or tilted away from the sun, and that happens in winter. For example, this axis influences the length of the polar night and polar day. At the North Pole and also South Pole, half of the year is polar night and half of the year will be polar day. If you go in the difference between the Arctic Circle to the North Pole, the length of the polar day and polar night will be different. For example, at the latitude 77 degrees north, this is where our Hornsund station is located. The polar night lasts from the end of October till the 12th of February. And the polar day lasts from the middle of April till the end of September. And then there are two transition zones when there is a night and day. So that's between February and April, and also between the end of August till October. The amount of solar radiation that reaches any spot on Earth is varies according to not only geographic location, also it depends on the time of the day, on the season, on local landscape, and also local weather. We know that if we want to know the climate of any particular place, it may be different at different locations. For example, different valleys, because the mountains surrounding the valleys, they also influence the local climate. So this is orographic control of the climate. There will be different topoclimate conditions, so very local, and there can be even different air temperatures and different precipitation depending on the valley, depending on the elevation, and also multiple factors. So once you want to talk about the climate of the particular place, it's very local, but then you can spread the measurements at different locations, and then you have information on the regional climate. All atmospheric processes, including radiation, convection, aerosol movement, play important roles in shaping Earth's energy and water cycles. And this water cycle is powered by energy from the sun. This is the most important factor again. And the water cycle is the continuous exchange of moisture between the ocean, the atmosphere, and the land. This is something that I provided within this picture. You can see the moisture that evaporates from the sea, then it condenses in the clouds, and then may fall back to the Earth's surface with precipitation such as snowfall or rainfall. If we think about the weather, and that's mostly thing that people discuss. We're interested in changes in the weather. So how cold it is now, how cold it will be tomorrow, what are the weather conditions? So what should I put on? What clothes? Will this be rainy tomorrow, today? So the weather is the state of the atmosphere at a particular time. And usually people use the description of the weather as something that has just short period of time. We don't talk about the climate because for talking about the climate, there has to be much longer time of observations, at least 30 years. So when you think about the climate, you can have, the average conditions for particular locations, but the weather is something that is day-to-day state of the atmosphere, and it's short-term variation in minutes to weeks. So it's not like seasonal or annual. It's just short period of time. So once someone says, "Oh, now the weather is colder during winter," so should we expect climate warming as there are few days with freezing temperatures? No, this is something that we feel. And this is something that we discuss, but for discussion on the climate, we need long-term observations. And people think about the weather as the combination of air temperature, humidity, precipitation, cloudiness, and visibility and wind. But once we observe those variables for a long time, at least 30 years, we can get the information on the statistical weather, average weather, for example, and normal conditions, and also for extremes for different locations. There is also comparison of the weather to the newspaper, like daily newspaper. And once we talk about the climate, it's the history book. It's not something that changes every day, but it's long-term period. There are 4 major climate zones of the Earth. The tropical zone is between the tropics, so between latitudes 23.5 degrees north and 23.5 degrees south, including the equator. There's also subtropics from 23.5 to 40 degrees north and south, and also temperate zone from 40 to 60. And there is also cold polar and subpolar zones from 60 degrees to 90 degrees latitude north and south. The polar areas receive less heat through the solar radiation, as I explained before. And since the sun has very flat angle, as it was shown towards the ground, the weather conditions are completely different than in lower latitudes. When also in Poland, in Europe, the weather sometimes in winter gets unusually cold, people say it's Arctic weather. And sometimes it is true because the Arctic air masses can spread southwards in winter. So they sometimes influence also weather patterns in lower latitudes. What happens in the Arctic doesn't stay in the Arctic. This can influence what and always influences what's going on in lower latitudes. In the far north, there are completely different climate conditions to those that we have in Poland and in Europe, but it's not always bitterly cold. You can expect also sunny days. There is short period of vegetation, so plants can grow, and it's not throughout the year, the land is not fully covered with snow, with frozen conditions. The snow melts during summer, and during this short vegetation time, the flowers can bloom and can grow. Here you can see one of them, Saxifraga oppositefolia, but there are multiple flowers and plants that consist as a tundra vegetation. When you think about the Arctic climate system, it can be characterized by low thermal energy because of the solar radiation that just slightly reaches the ground, and it covers bigger area because of the low angle. But it's also interactions between the atmosphere, the ocean, and the land that influence the climate in the Arctic. That's why scientists are interested not only in air temperature, but also what's going on in the ground, how the ground is influenced by lower temperatures. For thousands of years, the low temperatures made the freezing of the ground. So, and this frozen ground called permafrost in different locations can reach really low depths, up to hundreds of meters. But recently, what we observe with climate change is the deepening of the active layer. So the layer that thaws during summer and freezes again during winter. And that's something that influences the paths of water, how the water cycle works. And this influences vegetation, also the life of animals, but also all the infrastructure. And that's just one of the parts of the system that influences the climate, because there is also sea ice that is strongly connected with the air temperatures, and there's also glacial mass balance that is influenced by what's going on in the atmosphere. And the dynamic processes are the subject for different scientists, not only dealing with the atmosphere, but also glaciologists, geomorphologists, hydrologists, oceanographers. So what's going on there is part of really wide effort to know the processes and to describe them. Oceans have the capacity to store large amounts of heat, and this heat that is obtained by the ocean can be transported over vast distances. So for example, those red arrows that are shown on the map, these are warm ocean currents. The blue ones show the cold currents, ocean currents. You can see that in the middle of Atlantic Ocean, the warm current is moving towards the North Pole, and it influences the temperatures in the Arctic, in Svalbard. The furthermost part is Svalbard, as you can see, but it also influences temperature in whole Europe. You can see that at the same latitudes as Poland and England, in North America, there is Arctic Canada. So without this current, the weather and climate conditions would be completely different in Europe. But let's talk about Svalbard archipelago. This is where the branch of the North Atlantic Current reaches. Svalbard is the archipelago of which the biggest island is Spitsbergen. Sometimes people confuse those two names. Spitsbergen, just for remembering, is the biggest island of Svalbard archipelago. The western coasts of Svalbard are highly influenced by the West Spitsbergen current that brings the warm waters from the lower latitudes towards the north. At the same time, the eastern part of Svalbard is highly influenced by East Spitsbergen current, and this is current that flows from the Arctic Ocean from the north and floats towards the south, bringing colder water masses with lots of drift ice. And that's the main reason why most settlements were settled all across the western coasts, not the eastern coasts. Eastern coasts are rather and still high to reach because of the sea ice situation. If you look on Svalbard from above, you can see that the landscape consists of more than or around 60% of glaciers. It's highly glaciarized area. The rest is valleys and glacially eroded fjord systems. And these were the geographical factors that shape the climate. But once you do the observations and you collect this data, you can say something more about the average conditions. So the average conditions in Svalbard, the mean annual air temperature is around -6 degrees. For example, in Poland, it's +8, +9 degrees. The warmest month is July, and then the temperatures on average are +5, but you can also expect the higher temperatures for short periods. For example, noted temperature in Longyearbyen, the capital of Svalbard, reached more than 22 degrees during July. In winter and spring, the temperatures drop to around -15. There is also low precipitation, which is higher along the western coasts, where it reaches 500 millimeters. In central part, there is much less precipitation, so it's around 200 millimeters. So it's really not much. Usually you can expect not perfect weather there. It can be foggy. But once you compare the temperatures and also and precipitation on the left map, you can see the annual temperature at different locations. You can see the warmest is the southwest, and this is where our Polish Polar Station is located. The colder regions are further north and in the inner parts of the islands of Svalbard archipelago. There is also higher precipitation, as I mentioned, across the western shores. There are also clouds and wind conditions that influence how we feel in these conditions. Now I want to show you how bad it can be once there is the snow drift. This is how it looks during winter. Yeah, so during winter, during polar night, you can see that, it starts now. You can see that the conditions are so bad that it's really hard to go outside of our station. It's really not safe to go any far from the main building. So only basic measurements can be done, and the measurements that can be done, these can be conducted only in the near distance of the station. It's better not to go too far. We cannot measure any things on the fjords or on the glaciers because the weather doesn't allow us to go any further. But if you think that during polar night, it may be dangerous, so it should be less dangerous during the polar day, I'm going to show you the weather conditions in the end of April that I years ago. As you can see, it's similar. The visibility is really low, and drifting snow doesn't allow to go any further from the station. That's a distance of around 20 meters from the main building, and you can barely see where it's located. So the conditions can be very bad, and just that's something that you need to have in your mind, because normally during presentations, I also do this. I show better conditions because during sunny, pleasant weather, the pictures are much better than during rainy, snowy, or foggy conditions. So let's go further. Here you can see the seasonal change. These are two pictures of the station during spring and during summer. Yeah, so it's covered mostly with snow during winter and spring. There's around 250 days with snow cover in the surroundings of the Polish Polar Station. But during summer, the snow melts, the rivers start to flow, and the temperatures that are even above 10 degrees are also recorded and are rather exceptional, but can appear. February and March recently are the coldest months with temperatures around -15 degrees. But there can be different fluctuations on even during winter, even during polar night, because the ocean current also influences the temperatures during winter. So there can be also weather spells with thawing temperatures, rainfall, even during polar night. So you may think that it's only freezing cold, but also during winter it can be thawing conditions. Here's the picture that shows the snow cover in the surroundings of the station. When there is snowfall, it can be really high at the higher latitudes, altitudes, I mean. So the upper parts of the glaciers and upper parts of the mountains, if the conditions are okay, there will be accumulation of snow that can reach even few meters. 10 years ago, I worked as a meteorologist at the station, and something that is done continuously since 1978 is the meteorological monitoring that is conducted by the Polish Polar Station Hornsund, not only by this station. It's done at thousands of meteorological stations around our globe. Meteorologists that work, they acquire, process, and interpret the data they collect. And this data is further used for understanding the climate conditions, and they are also used for producing the weather forecasts. And that's the picture of the our station, Hornsund, during summer. During spring, you can see the meteorological site with all the equipment that is used for measuring the atmospheric conditions. All data that is collected at this meteorological site helps to characterize the climate of the Atlantic sector of the Arctic. So it gives us the information about the climate change in this part of the world as it is continuous. And I told you that the long-term observations are needed to understand how the climate behaves and how it changes. There are multiple instruments such as ceilometer. For example, ceilometer measures the base of the clouds, also aerosols in the atmosphere. There are also pluviometers, rain gauges, in other words. They measure precipitation. There are also radiometers that measure solar radiation. We also have automatic weather stations with all the equipment that is put on the mast. So this includes thermometers, barometers, hygrometers, and anemometers that measure the wind speed and wind direction. And in the past, in Hornsund, we also used LiDAR that provided the information on the aerosols in the atmosphere. Here are the parameters that are measured by our meteorologists. In the past, it was just 2 meteorologists, so they worked on one-day shifts. And for the last few years, we have 3 meteorologists that work throughout the year at the station, and then they collect data on air temperature, precipitation, air humidity, wind speed and direction, atmospheric pressure, also ground temperatures are measured, and also total sunshine is measured. The observations that are done by the meteorologists include the cloud cover and cloud types, visibility, snow cover, snow water equivalent. So it's not only measurement of the snow depth, but also how much water can be melted from given snow depth. They also describe the weather phenomena and do the measurements of the temperature of the fjord, water temperature, and also sea ice cover. If we look at the average temperatures for the period 1979-2019, we know that the annual air temperature is around -3 degrees at Hornsund Station, with the maximum that was recorded in 2020 plus 16.5. But at the same time in 2020, we had different thermometers in valleys surrounding Hornsund Station. So this is data that comes from the meteorological side, but just in the valley, some 5 kilometers from our station, we measured 22 degrees. The minimum recorded was -35.9 degrees in 1981 in January. Maximum wind speed that was recorded reached 176 kilometers per hour, so really strong wind. If you're interested in the weather conditions in Hornsund, you can check our station website, hornsund.igf.edu.pl, and you can choose in weather. There are meteorological bulletins that are published by our meteorologists every month. So you can see the current and past weather conditions there. What we observe in the Arctic is the ongoing climate change that has huge impact on Arctic regions. And these are very sensitive geoecosystems, and they lay far away from the direct anthropogenic impact. So this is pristine environment that is far away from civilization, but it's also influenced by this far distance. So what happens in Europe also influences what's going on in the Arctic. And there are, what we try to understand is those impacts and consequences of climate change into the local conditions. In recent decades, we observe warming, and this is something that is proved by our collected data. Data collected by meteorologists at our meteorological station. And we summarized the conditions, and that's something that you cannot feel on daily basis because average air temperature, annual average, is something that is only visible in the data. You don't feel that. You feel just on daily basis, daily variability. But here we compare the data of the average air temperature, annual average, and you can see that on average in the 80s in the past century, on average temperatures in Hornsund were around -6. Recently, it's even less than -2 degrees. So it's 4.5 higher temperature, higher annual air temperature than in the past. There is also change in the precipitation amount, and what we observe is higher rainfall, not the snowfall in Hornsund. So that's something that is also influenced by the climate change. What we see is that if we average the data, we see that there is higher temperatures during autumn, winter, and during spring, and slightly higher temperatures during summer. In case of precipitation, we observe much more rainfall during autumn or fall. With our colleagues from different institutions, from different meteorological sites in Spitsbergen, we compared the trends of these temperatures, and we observed similar trends across all stations, meteorological stations that are located in Svalbard. You can see there is clear evidence of warming of the climate. It also influences the snow cover. From that, we know that the snow cover lasts shorter than in the past. And comparing to the 80s of the previous century, the snow cover lasts some 1.5 months shorter than then. So that's a long period without snow. Snow melts faster in the year and appears later in the year. So there is longer period without snow cover. Also, sea ice conditions are influenced by climate change. What we see is the reduction of snow and ice that has the effect of increasing warming trend, as reflective snow and ice surfaces are replaced by darker land and water surfaces. So in easier words, once you go out during summer and you wear the black t-shirt, this will you will feel much warmer than if you wear white t-shirt, because the solar radiation is absorbed by darker t-shirt. And the same thing happens with dark ocean and dark land, which is not covered with snow or ice. So that's something that we also observe. And this shorter snow cover period influences also how the rivers behave. It also influences the permafrost conditions and multiple processes that we observe that are ongoing due to climate change. And according to all the simulations of future climates, the temperatures will grow. And in the end of the century, there may be even most of the year without freezing temperatures. So the temperatures will be positive throughout the year. And that's something that influences the mass balance of the glaciers. On this map, you can see the Hornsund Fjord with those lines that mark the extent of the glaciers in different years. The yellow in the middle, you can see it's 1899, so more than 100 years ago. And since then, all the glaciers in the surrounding of Hornsund Fjord retreated. So we observed that the fjord is bigger than in the past, but the glaciers are much smaller than in the past. Here is comparison of two satellite images, July 1990 and July 2017. You can see this is the clear evidence of the retreat of the glaciers. If you go to the field with some old images, you can also see that. And actually, that's the best way to have this visual observation. In the upper part, I show you the picture that was taken in 1999, then 2008. Below, it's 2014 and 2020. So you can see how the glacier retreated in this period of 20 years. But you don't, if you haven't been in the area, you may not know the scale of this. So please look at the middle part of this bay in the glacier, because I want to zoom in there. And here you can see the front of the glacier. This is the front that reaches up to 40 meters above the sea water, above the fjord. And you can also see my colleagues, glaciologists, on the way to the glacier. They are really small in comparison to the scale of the glacier. So that's something that is also one of the subjects of our scientific efforts. And that's something that you probably saw in the media, because we also not only publish the scientific papers, but we also from time to time discuss with the media. So maybe on ONET or National Geographic or in different places, you might have seen that information. The science on the human contribution to modern warming is clear. The emission of the greenhouse gases influenced and caused 100% of the warming since the middle of the 20th century. So it's clear information that pumping all the whole emission of the greenhouse gases caused the warming effect in the atmosphere. So what we should know is that we need to think how to reduce the emission of these gases if we want to go back to the stabilized climate.